So let's continue. Please welcome back Nestori for the 5th time at the Troopers stage. He will show us how Windows uses the TPM to secure PRTs.
Thank you, and welcome everybody. So my name is Dr. Nestori Syynima, and I'm here to talk about E7 licenses. Just kidding. So let's go back here. So the title is that how Windows protects PRTs with TPMs, and it actually doesn't. It is protecting session keys, but basically same thing. So I already told my name, and I work for Microsoft currently in an organization called Microsoft Security Research. Let's see what it will be next year. And I work there as a principal identity security researcher. And my job is basically find new attack paths before bad guys do, and then help to fix the products, and also like help build detections and disruptions and so on. And I'm also the guy who made the tool called A18 internals, and we have new Troopers branded stickers, which you can get. You can get your one from the sticker lady here after the talk. Okay, so this is my 5th time. When I first was here, I was 45 years old, so now I'm 50 years old. And I actually organized a cruise earlier this year, a hacker cruise, where I took a group of my best friends all around the world to Helsinki, Finland, and then we went to a 22-hour cruise to Tallinn, Estonia, and it was interesting, very funny. And I don't know who have been in that kind of like ferry. So basically it's like a floating nightclub. And there were guys from Sweden, Denmark, the Netherlands, the US, and what else? Did I forget something? Finland, of course. And it was I had a no-gift policy, but George doesn't believe anything what I tell him, so he brought me wooden shoes, or gloves, I think they are called, from the Netherlands. And I don't have them with me now because I heard that there's a carpet and it might be a bit slippery. And then I had another party for my local Finnish friends, and it seems that I like to do a lot of dancing and have a funny hats and hair. But yeah, that's me. But luckily, these conferences are not anymore like only middle-aged men like me and Eric, and not almost middle-aged men like Thomas and others. So there's also quite a lot of women here, like the keynote. Sapir is talking also tomorrow, right? Today, okay. Okay, oh, I'll try to be here. But anyway, so there was a line from the last slide of the keynote, so that the research is curiosity-driven, and it produces possibilities. And here's kind of a map about scientific thing. So basically what this tries to tell you is that there are multiple points where you can start your research, and only some of them leads to some findings. So it's kind of like me as a researcher, and some of you who are also researchers, you know that you might be studying something like 6 months, and the outcome is that, well, dead end somewhere. Who have done that? I know Dirkjan has, and others. But yeah, that's how it goes. And this is a story of one of those kind of researchers. So let's see how this goes. So here's an example how things evolve. 1996, there was a guy called Mark Russinovich who created a tool called sysinternals. You know what's coming next. DS internals by Michael Grafnetter, and now it's in perfection. We have A8 internals. Well, there's also something from Fabian, but let's not talk about that. So basically, this means that we are building on top of each other findings. Well, this is not the same tool, so the tool didn't evolve, but more like the basic same idea. I'm creating a tool for something new that is doing something that is not officially supported or shouldn't be possible. Okay, so today what I'm going to talk about are these kind of things. So first, short recap to Entra ID join, then introduction to TPM, then combine these two things, and then we're going to do some attacks toward TPM. Okay, so Entra ID join recap. So what happens when your device is joined to Entra ID? So there are two key pairs that are created on this machine. So one is for device, and another one is called transport key. And the public keys are sent to Entra ID, so that they know what they are. And then they can use those keys to decrypt things, encrypt things, and then your device can do it vice versa. And the most important thing here is the transport key, which is used to encrypt and decrypt PRT session key, which you need to have to use the PRT, or primary reference token. And here's how it goes. So first, on the device, you need to get access token, so you need to log in and say that I want to join this device to Entra. You will get access token, and then with that access token, you are sending a CSR or certificate signing request to Entra. Entra signs that and gives you back signed device certificate. And now that certificate proves your device identity. Okay? Now, then PRT. So what happens? So you request a PRT that is signed with the private key of this device certificate. So it proves the identity of the device, right? And then you also need to prove your identity. So it could be username and password or something else, but usually that still. And then what you get back is the PRT and the session key. And the session key is encrypted with a transport key, public key, which means that you need to have the private key to, decrypt that. So technically, this session key JWE is based on standard called JSON Web Encryption. So it's pretty much same as JSON Web Signing, but it has more parts. So we have the Jose header, which tells you which encryption method you used here. Then you have the encrypted key, which in this case is session key. And then you have some stuff that you need to have to be able to decrypt that, like IV and ciphertext. IV and ciphertext is what you basically decrypt using this key. But in this point, you just need to remember that there's the session key. Okay. So where these keys or certificates are stored, if you don't have TPM on your Windows laptop, so the cert is in local machine, personal store, and the key is probably here. Well, not probably, it is there. For the transport key, it's in the different part of the disk, so it's in system keys, and then the PRD and session key are located in what's that called? Cloud AP cache. So they are on disk. Okay. And all these things are exportable by local admin if you don't have TPM, which means that if you are a local admin, you can get access to those and you can use them, which is not a good thing, right? So let's show an example as a demo. And I have a lot of live demos. I only do live demos, so let's hope everything goes fine. So what I'm doing here now is that I'm joining this device to Entra. Just a moment. Let's hope the network is working. Or otherwise, we are not going to have that nice demos. Okay. There we go. So join this device. Okay, so at this point, I'm going to jump to my AAD internals for endpoints toolkit. I'm going to load that. Okay, and it says that we have MDE real-time monitoring enabled. Just switch that off. Try again. Okay, and now we have Troopers edition, by the way. And I'm going to publish that at some point, but I'm going to set the proxy settings of this device so that I can see what's happening when you do the join. And then I'm going to start Fiddler, which is my go-to tool for network monitoring. I think most of you are using Burp Suite or something like that. But now when I click join, it joins the device, and we can see that what happened. And now it says that you are all good to go, so that I should now log in as that other user. But let's go here first. So what is sent to Entra? So you have the certificate request, and then here we have the transport key, and they are sent to Entra. And then what comes back is the device certificate. Okay, so at this point, we can try to export those. Okay, the mouse is a little too fast. So first, the device certificate, which we can use to request PRT, and then the transport key, which we can use to decrypt the session key. Okay, so we can do that, so it's doable. So next what I'm going to do is that I'm going to now log in. There's my Hyper-V there. So you can't see anything because I'm running it in another display, but okay. Once more. Maybe I'll just show it to you anyways. There we go. Okay, now we can see that things are happening. And here is the request that we used to get the PRT. And here we have request token, which is a PRT. And then we have this session key JWE. Let's zoom it a little bit. So this fellow here. And that is now encrypted with the session key. And now we have the session key, so I think we have time for that, so I will demonstrate how you can use those like offline. Okay. So first, let's go here. So there's the PEM for transport key. I'm going to copy that. Then I'm going to open PowerShell, and this is on my local machine, so it's not one of those VMs. I'm going to paste that there. So the private, now we have the transport key, and then I'm going to copy this one here. Oh, well, just paste it there, and then I like PowerShell so much. So now I'm just going to play this, and it should end up with the session key. So Q, Z, SH, and so on, and ends with BG. And so that demonstrates what you can do. So if you have the transport key, then you can like decrypt those session keys, and then you can use that and the primary refresh token. Now what else we can do? Now that I have logged in and that the PRT is stored in the cache, I can run this command here, and that is going to the cache, and it's going to extract those things. So only thing that you need to do that is that you need to be a local admin, and that you know the user's username and password in this case. And because we are hackers, we know that, right? But anyways, so here's the same session key, Q, Z, SH, and so on. Okay. So that's how Entra ID join works. And then with the PRT, you can go and request access tokens to any services you want to. OK, so then to TPM. Who knows what TPM is? Yeah, you think. That was my thought exactly. But yeah, so what is a TPM? So we have the host system. So let's say my Windows laptop here, and then we have a TPM. So it stands for Trusted Platform Module. And we are talking about actually version 2 something. What is the latest? 2.1, 2.2? Anyways, yeah. But when I was studying this, I was reading documentation for TPM1, and things didn't work that well. So anyways. OK, so it's a separate computing unit. So it's not like technically it's a chip on your motherboard, but it's actually another computer that doesn't serve pretty much anything with the host. And only way that you can access those keys here is that you can't. You can only ask TPM to do that for you. And you communicate with the slow I/O channel, which means that it doesn't transfer like gigabytes in a millisecond, but more like kilobytes, something like that. But anyway, we can access the keys. We can access the API that then can access the actual keys, which are inside TPM. And when I say that inside TPM, this is just logically, so they are not necessarily actually inside the TPM, but that's about the next slide. So my perception before I started study was that when I have TPM, the keys are always inside the TPM. Who thinks this way also? OK, you can raise your hands. But that's not the case. So what happens? So when you create or you ask TPM to create a certificate, it is encrypted with the TPM's storage root key. Like here, for instance, key 1, it's encrypted with that. And then that is sent outside the TPM. So you have a file outside TPM that is encrypted with the TPM storage root key. So that's protected by TPM, but it's not stored on the TPM, technically. OK? And then you have a hierarchy. So all the keys have parents. So for instance, key 3, it's not encrypted with the storage root key, but it's parent. OK? You can also import things from outside. So let's say that you have other TPM, or you have your own keys that you want to use in TPM. You can import them. And then happens the same. So when you import the key, you need to also provide like a public key, which is used to decrypt that. And then TPM is encrypting that again, and then it throws it out. And in Windows, technically, those are stored in PCP key files. So if you find out that some certificate has a private key that is ending with PCP key, you know that that's protected by TPM. OK, so as I said, the keys are not typically inside. You can also store them there, but there's not that much space. So that is possible, but out of the box, it doesn't work like that. OK, so now that you have created or imported the key, or you have the PCP key, you can then ask TPM to load that. So now it's loaded to TPM for that session. So we have also a thing called session. And it's there only throughout that session. And then when it's loaded there, then you can use for cryptographic things. But if you have like a hierarchy, so in order for you to use key 3, you need to first load key 2, and then you can load key 3, and then you can use them. Yes. OK, and then when they are loaded, you can use them to encrypt or decrypt stuff, or sign stuff, or check the signature, or validate signature. OK? So far, so cool. OK, so how to use TPM on Windows? The easy way. OK? So we have a CNG API, or it's called the Cryptographic API, the next generation. I wonder which kind of like a movie thing have, used in here. And if you have the provider called Microsoft Platform Crypto Provider, then it's using TPM. OK? And your application is talking to the CNG API, and then that is talking TPM for you. Okay. And if you are a developer, that API works in similar way, regardless is it using TPM or not. So you don't need to care about that. So you just want to say, okay, I want to load this key. You just provide the key ID, and it will do all for you. So it will find the key for you. Okay. So I want to know what happens under the hood when you are doing this with endpoint with TPM. So I already showed you Fiddler, so I'm using that to see what happens between this endpoint and cloud. And then what happens on this endpoint, I am using Rohitap API monitor. Who is using that? Yeah, it's an old tool, but still quite good. And then if nothing else helps, then I'm using debugger, because it shows everything. It turns out that LSAS process doesn't like that it to be monitored. So whenever I'm using Rohitap API monitor, it may or may not crash. We'll see. I have a live demo about that now. Okay. So next I'm going to change to Windows 10 with TPM. So why I'm not using Windows 11? Because the function that is used here in the background is changed now. So it didn't work in Windows 11, which I learned like a day before yesterday. But anyways, so let's do the demo. So same thing. Let's hope that the network is working. Okay, I'm going to connect. And we're going to join this device to Entra. I'm missing Contoso. I haven't updated my slide text to that SAR or whatever that was. Nowadays used. Okay. And we're going to do the same thing here. So import the module, disable MDA real-time monitoring, load it again, set the proxy. And it's crucial that you remember to start the proxy, because otherwise it... And by the way, why I do it in that point? Because if a proxy is enabled when I click the connect button, it doesn't work. So you need to be patient and start that only after you get that box, which is this one. And here you can enable the proxy. I say join. And I go here. We can see the same stuff that is sent there. So certificate request, we have the transport key, and then what comes back is the, well, actually it was already there, so the signed key. So everything in the same way. But now, because the keys are stored on the TPM, so when I try to export the device certificate, this is what happens. So it says key not found. Well, it's found, but you can't use that. And same with transport key, but now it says that it's TPM bound, so you can't export that. Okay, so things are a little bit more difficult now. Okay, so we can't do that yet, so I need to go to my Hyper-V. And the other user. Okay, and when we go back here, we can see stuff happening. So here we are asking for the PRT, and here we have refresh token right here, and then we have the session key WE. But this is like much bigger than with the one that doesn't have a TMP. So that was like 300 characters, and this is over 500, almost 800. I guess it depends a little bit. But anyway, that is stored in the Cloud AP cache. And again, because we are hackers, we know the username and password of the target user. So let's try to export that from the cache. And it is there. So, but it's encrypted with TPM. Okay? And it's the key that is used to encrypt that is actually the transport key. And this is the name of the transport key. Okay. So, so when you are studying this, like which APIs are called in your endpoint, it's quite like big work to always join the device, like do all those typings and so on. So I made a little utility for that I'm using internally. So that's also a tip for you that please like use your own tools or critical tools. So when I dump this thing, it's also saved in a JSON file locally. So I have a command here that first it's reading those settings as an object, and then it's doing that to decrypt the key. So whenever I run this, it actually does the same thing that I would do that like the joining thing. So just one liner. And maybe I'll just show you the content of this file. So how that key looks like. Desktop, troopers, and key. And those who know, yes, it's turned off. And those who know like what kind of the key files are, so this doesn't look like a key file to me. But it is, that's what's like how it looks like when it's decrypted by TPM. Go away, okay. Anyway, so when I run this, it emulates the join process. So now let's use this API monitor to do that. So I'm gonna find LSAS here. Gonna start monitoring that here. Go here, and I'm gonna run the command like this. And now we have some calls here. And now let's do stop monitoring. And let's pray. Nice. But I'm still gonna save this. Because usually at this point it's the 50-50. Windows says, okay, that's the bad thing. I'm gonna reboot myself. Okay, so what do we need next is that we need to have a name of this key. So with API Monitor, you can choose which APIs you want to monitor. I have selected a few here. And when I search the key name, we should have a call for that, encrypt open key. So, okay, so this way I was able to kind of pinpoint that. That's the place where I want to be. And then I see that there's an NT create file. And if I expand the this is let's do it this way. Make it a little bit bigger. So object attributes, object name, Unicode, something. And if I click here, we can see here that it is opening TPM. Okay? And therefore, noticed something like this. TBSI get device info. Who has heard about this? Me neither. So I hit the Google, and it shows that, okay, we have a documentation for that. And then I noticed something interesting right there. It said tbzip submit command function, okay, and there's also like a description for that. So it submits a command to TPM using TPM base services, or TBS. So that also means what the TBS stands for. And here is another thing that is interesting. That is a PAB command. And what it is, it's a pointer to a buffer that contains TPM command to process. And that's a binary stuff. So you need to know what you are sending there and whatever is coming back. So how to use TPM on Windows the hard way is to communicate directly with TPM using these TPM-based services. So now you don't use the CNG to do stuff, but you talk to TPM. You just need to know the language of TPM. And you are using this command to do that. So that's the function that you need to be able to call. OK, and I was, yes, this is interesting. And as I told you, remember this is TPM2. I was reading the documentation of TPM1, and anything didn't make any sense. But I finally find the correct specification. That is actually like from the last year, the latest version. So you can click the links whenever you get this, and you know like what happens. But anyway, so I have the documentation. Who has tried to implement something based only on documentation? Because it really doesn't work. Well, usually it doesn't work. And especially the company I represent doesn't always follow the specifications that well. So I had to be able to see what is going on in there, so what is happening. And that brings us to the last demo. So actually, I think it now rebooted. So. Oh, no, this is the wrong one. No worries, it didn't reboot. Here we go. So actually, if we go a little bit down here, you can see that there's a TPS DLL making a memory copy. And this actually here is a TPM command. And the 173 says that give me device information. So that's. But anyway, so you could also see things here. But the challenge is that you have a limit to the buffer, so it's 1024, so it's 1 kilobyte, so you can't see everything. How much do I have time? Because they are clapping. OK, good. OK, so they just finished early. OK, so that's why I'm using X64 debugger, which I have here. I hope I remember everything. So first I'm going to attach this to LSAS again. OK, so now it's attached to there. I have some breakpoints here. So I think encrypt. So couple of things like import key and export key, also for TBS. So submit command and create context and close context. So context is like a session. So I wanted to monitor that. So let's go here. And for some reason it already got something because it's pausing on everything. So let's run the command here, like this. And now we come to what? Crypt export key. We are not interested on that. Not the import key, but here, submit command. So what is nice with this debugger is that you have these different dumps, and I can press S, and then it asks me, or does it? That what do you want to put here? I want to put here registry 9. Don't ask how I know this, but anyway, so here's a 8000, and this is again like a TPM command. And here I want to see the result, and that is in registry 14. So it shows the reply. So now when I go, so here I can see what this means. Then I can go back to the documentation and see that, OK, what's happening here? And then when I run to return command, let's do it here. Is it here? Execute till return. And then I switch to another thing. I can see the reply. So this way I was able to see that what really happens there. So I was able to talk to TPM and try all the funny stuff. So basically I had the basics found out. So now I can really do my research. And I still have like about 15 minutes time to go. Okay, so what I learned from this. So yeah, so part of my presentation usually is also to show you the tools, how you can use them to find stuff. Oh, by the way, one funny thing. So this is LSAS, so now it's paused, which means I can't do anything else but use this. So if I want to click this, it doesn't open because LSAS is frozen. So if you want to copy paste something, that doesn't work. So you just need to take screenshots. So I have a OneNote, like a full of screenshots, and then I'm trying to OCR that whatever there is. But or then you can also like record this in video. But yeah, just good to know that when LSAS is paused, you can't do anything else. Okay, so what did I learn? So the command load. So when I'm loading the transport key, the content is actually the same that we have in the PCP key, except that the green and the red part have changed places. So basically, the PCP key is a TPM command, which you use to send there. Okay? Same with the session key. So the session key that was in the cache, that was I was able to decrypt. It looks like this on the right, so 10 something. And when you use the import command, it's the same content, but again the parts are different. And how I noticed this, again like a good tip is that always have this hash dump somewhere. So if you paste some hex values on one window, then you can search those from the other window. And if you find a match, oh, okay, there is something here. Okay. So when Enter ID is joined with a device with the TPM, so what happens? So again, you are creating a key pairs by TPM, and those key blobs that you get from there are sent to Entra because they always contains like a public key. It's not encrypted anyway. And then they are sent to Entra. And the session key is actually a 3-part blob that has an object public, which is the public key. Then we have the duplicate, so it's the encrypted key actually. And then we have a SIM seed, which is another thingy. Don't ask details, but you just need to know they are like 3 different parts. Okay, and where these are stored? Well, the keys are still on the disk, but they are called PCP keys. Okay, both the device and the transport key, and then the session key is stored in the cache data. Cache data, yeah. Okay, and these all are exportable by local admin, but you can't use them unless you have access to TPM. Now, can like a standard user call TPM? Anyone? Can, yes. So how come is the session key protected? Because the file where it is protected. So you can't access that unless you are a local admin. But when you have that, then you can call TPM. Okay? So TPM is open for everybody. So it's up to the host operating system to, secure the files that you shouldn't be accessing. So we have the TPM. There's a storage key, and that maps to the PCP key. So it's a transport key, and then we have the session key. So in order for you to be able to use TPM to decrypt session key, you need to, use that. You need to have the transport key also loaded there, and then load session key, and then you can sign stuff with that. Okay, so last part is attacking things. This is the most funny part. So research setup. So we know that when the attacker is on target device, they can request new PRT and session keys because they have access to device certificate. And they can also request new PRT and session key, and they can decrypt those also because they are, use them because they are local admins. So but the research question for me was that, okay, so if we have all these keys lying around, so can we actually export the session key? So I have 4 tests, so let's just jump to them. So the first one is to duplicate session key. So this is a TPM terminology. So TPM duplicate is made for the purpose that is that, so you have a TPM, you have a secret there, a key, and you want to transport that to another TPM or outside the TPM, or maybe another parent. So also in TPM, you may want to move that to under key 2 instead of key 3. Okay, and the documentation says that if, so each of the objects inside the TPM, they have also attributes or properties. And one of them is like, is it fixed to a parent or is it fixed to a certain TPM? And then you have the policy that defines that, like for instance, for this command, there needs to be a duplicate policy. So TPM, CC, duplicate. So that policy needs to be there. Okay? And I was studying this that, okay, these are not set. So this means that the session key can be moved outside the TPM and can be moved under the different parent, which is great. But what about the policy? So the policy was empty. I was, yes, this sounds good. But when I tried to do that, it says that the policy check failed because there was no policy to check against. Okay? So this failed. As a researcher, this is always, haha. Then I had so I just had to make sure that that is actually possible. So I created my own certificate with the policy set there. So I created that. So now it has so that that was not like same way as the session key. So it's not bound to certain TPM or parent. And I also set the policy so that you can do the duplicate, and it was successful. So I knew that this can be done. So is it doable? So then I tried to do this. So this was the original thing I tried to duplicate, and in place of auth policy, it says 0, it means that empty buffer. So there was no key. So I modified that. So I added there that, okay, the size of the authentication policy is 32 bytes. So this is in hexa, okay? And then I put the authorization or authentication policy there. And then the documentation said that TPM is using a secure hash function so that we can alter the content. And that is in the in-sim seed, so third thingy, or third part of this thing. So there was this public key, private key, and then this sim seed stuff. And that is like, luckily, it is encrypted with the public key of the certificate or the object. But because we don't know what's inside that, I couldn't recalculate that, so it failed. So no can do. Okay, the first and final test. So you've been seeing my failures here all the time. So the last idea was, so what about I'm using like TPM functionality, which you can do the decrypt thing. So there's a function called RSA decrypt, which is used for obviously decrypting stuff. And documentation says things again. So there's a certain integrity value in the content of the key that you can say that, okay, you can't do this, basically. So if these both are true, so it is restricted and decrypt, so those attributes or properties of the object, then it's using a certain hashing thingy, and it's failed again. But if those attributes would have been like false, even one of those, this would have, worked. But it turns out that we did something very well. So you couldn't do that. Okay. So the summary of my failures are as follows. So without a TPM, threat actor can steal the identity of your device and you, if you have PRT, and even your MFA claim, if it's there. And then it can be used both locally and offline. So they can get the key material, they'll go away, and they can fake your device and identity offline. And with TPM, they can export those stuff, but they can use them only, they can use them only locally. So keys are safe with TPM, even though they are not inside TPM. They are outside, but they are protected by TPM. Okay, so for detection, so how to detect this stuff is to monitor access to key material. That's a bit noisy because that happens all the time. And then you can also monitor authentication events in Entra, like somebody's suddenly logging in from a different device or different location and so on. Okay, with that, thank you for listening. And this is only AI content I've ever created to my presentation, by the way. Angry man yelling at clouds. Okay, thank you.